Okay, so part 3, and the foot, the cubit and the metre, and these nice connections, especially this 5/6. But began with this pendulum is set as exactly 1 metre, which is defined by the speed of light. This pendulum is the historic 1 second at 0.9943 metres. So 1 second, still this nice thing, but 1 speed of light metre, okay, also 1 English foot is a fraction short of 4/7 of Egyptian Royal Cubit, and that difference of 5.601 mils will bring us to, so 1 metre minus 1 foot minus 4/7 Egyptian Royal Cubits brings us this older definition of the metre, which is based on a second. Metre and second are connected. Speed of light per second is the definition of this metre, which gives us the Royal Egyptian Cubit. 1 Royal Egyptian Cubit is pi/6 metres, or E minus 1 feet. Metre, cubit and foot relationship. Now let's look at the Indus, the Cremona and the Canonical Cubit. Okay, before I go on, 1 Egyptian Royal Cubit defines a pyramid. So for instance, the base 440 by 280. Multiply this by 440, you get the base. Multiply this by 280, you get the height of the Great Pyramid. Now all of this will come back to other, okay, also that section of arc. So the whole arc is pi/6 metres. So then this portion is phi plus 1 over 10, or phi squared over 10 metres. Phi, pi, e, some of these important constants, which brings us back to the second, the metre, and of course the speed of light. And the margin of error between this one and that one just happens to be a nice relationship between the speed of light metre of a foot and the Egyptian Royal Cubit. Also worth noting that the Giza Plateau is 30 degrees north of the equator, 30 degrees being this all-important angle to create a proper pendulum. If you go too far, you lose the timing. It has to be a shallow angle, no more than 15 degrees from resting. But how does the Indus, the Cremona and the Canonical Cubit go? Well, now we've already established this, so I'm going to change this pendulum. So we established the 1 second pendulum and this connection here. So what I'm going to do now is change that. And let's imagine I stretch it out a little bit. And what I'm going to do is bring in the Indus foot. Indus civilization, Mohenjo Daro and Harappa, for instance, the famous cities of the Indus. How do they connect with Egypt? Well, apparently they don't. But just by coincidence, in Egypt, gold Devon was 13.66 grams. And that's gold, and the copper Devon was 27.3 grams. Now 27.3 just overloaded with info there, but what weights were they using in the Indus? Well, they found all these small cubes, and they go in a scale of 1, 2, 4, okay? So, well, 13.6 grams and 27.3 grams was also being used in the Indus Valley civilization 2500 BC, same as the Old Kingdom in Egypt. But this, of course, is all a nice coincidence. Now, it's also worth mentioning, so that's that section of arc. So let's get rid of that for a moment. And if I was to draw a line straight across from this point to this point, that would be half a metre, 50 centimetres, but this turns out to be 0.2734 yards. Now I can get even closer, but that's got to do with medieval cubit, we'll come back to that eventually. 273, the height of the Great Pyramid is 27.33 Doric fathoms. And you just find all these ancient sites all have this number, but that's, I'm diverting now. What I want to go to is the Indus foot. 12-inch foot, the Indus foot is 13.2 feet, or 1.1 English feet is 1 Indus foot. It's also pointed to in Sumer, but also up until just before the English foot was introduced officially by Edmund Gunther and Queen Elizabeth I, the Saxon foot was also at 1.1 ratio. So this is 1 metre. 1 metre is 3.2808 feet. Now, what if we make a yard of the Indus foot? So that would be 3 feet, make a yard. So now we're going to change this pendulum. Imagine I stretch it out a little bit to 3.3 feet, or 3 Indus feet. That is equal to 1.00584 metres. So you're just adding 5.84 millimetres to this one, 3.2808, 3.3 feet. Now still you've got a very, very close second there, but because it's longer now, you've changed the arc. This portion is now longer because, okay, 3 Indus feet is the length of the pendulum, therefore the greater circle would be 6 Indus feet, 6 times pi, then we divide it by 1/12 or 30 degrees. So by definition, this would be exactly pi over 2 Indus feet. Exactly by definition. Now, this would also create, so we have the Egyptian Royal Cubit pendulum, 52.359 metres. What this would create is a pendulum of it would basically adding 3 millimetres to it. It would be 0.526656 metres, which equals 1.7287875959 feet. 1 ERC equals E minus 1, or 1.71799, a hair's different, literally even less than a hair from E minus 1. This important constant, we saw the phi appearing in there, and pi over 6 metres is 1 metre. That also pi over 2 Indus feet gives us this different unit, which is 1.7. So again, splitting hairs from 1.728 feet. Because the way the circle and pi works, it's not so surprising that this would be pi over 2 Indus feet, or 1 Egyptian Royal Cubit plus 3 millimetres, a grain of rice. Just to make it clear, I'm just going to invent a term for this, the Indus Royal Pendulum Cubit, the IRPC. That's what I'm going to call this. But what's important is, so we have the Indus foot, and we also have the Canonical Cubit, which Michel and Robin Heath have spoken about. And 1 Canonical Cubit is 1.728 feet, or 6 over 5 cubed. 6 over 5 cubed, or 1.728. 1.728. Again, it's 0.8 of a millimetre difference between the 6 over 5 cubed to create a canonical cubit and this, 0.8 of a millimetre. But what's also, how does this connect to the Cremona scale? The Cremona scale basically disappeared in the 1800s. You'll see it in older texts, and then it seems to have vanished. What it was, 7 feet equals 6 Cremona. That's the ratio, 7 to 6. Now, why is this nice? Because, well, the Indus, the Cremona and the Canonical are going to come together in a very, very lovely way, because Where's the exact number? Okay. 2.734 yards, the line directly across. So if we draw that line, which is 25 centimetres, or okay, that's just a natural relationship. We have this Indus Royal Pendulum Cubit, as I'm calling it, an Egyptian Royal Cubit plus 3 millimetres, which just turns out to be a Canonical Cubit. But because now it's a little bit longer, we've added 5.8 mils to the speed of light metre. The Cremona scale, 7 English feet equals 6 Cremona. And this turns out to be 1.4142 857 142.857 142.857 repeater. The square root of 2 is 1.14142. Square root of 2, Cremona, square root of 2 there. This is an important bit of math knowledge. Pi over 6 metres, a cubit to the metre. E minus 1 feet, a foot to the cubit. And we have this, well, how does this connect? So, well, the Indus and Egypt, both using 27.3 grams, which in itself is loaded. Let's get rid of that, because now we want to look at the size of the earth and how it connects to the pyramid. So this official metre, defined by the speed of light metre, gives us a Royal Egyptian Cubit on the pendulum, which multiply this by 440, you get the base, multiply by 280, you get the height of the Great Pyramid. Now, it's often said that the Great Pyramid is connected to the size of the earth and they use 43,200. Well, it's correct, but I think it's more elegant to do it this way, because again, we have this connection, metre, cubit, foot to the second, 86,400 seconds per day. That's 43,200 times 2. But also when they scale the pyramid to the size of the earth, usually they use a top view and they work out the perimeter, and then they use the height, and what happens is that you only get half of the earth. So you get the polar radius and the equatorial circumference, which is still very nice. However, let's look at this number and how it applies to the Indus Royal Pendulum Cubit, as I'm calling it. So this 43,200 relies on basically looking at it two-dimensionally, a bird's eye view, then a cross-section view. Okay, but what the pyramid is actually, it's three-dimensional. And so if you stand at the corner of a pyramid, the most you're ever going to see is two sides and the height. Now, what actually happens is that there's these little things, little blocks at the corner, like indents, which are sort of like structural elements, called the sockets. Now, the pyramid also sits on a roughly 55 centimetre layer of paving stones. So the sockets add a little bit of length and the paving stones add a little bit of height. If you include the sockets and the paving stones and you look at that number, okay, so multiply the Egyptian Royal Cubit, which comes from the speed of light metre, you just get the pyramid itself, just the pyramid, which has all this info in there. I'm just glancing over that, but now we want to get it to the size of the earth, and we're going to use 86,400 second metre cubit, 86,400 seconds per day. So if you include the sockets and you stand at the corner, because that's the maximum visible, okay, you're going to get a little bit more. It's going to be basically about 4 extra feet. I can't remember the exact number offhand. Okay, so what happens if I stand at the corner and I include the sockets? What I get is 463.45 metres, something like that, roughly that. Now, not roughly, very, very close to that. if I stand at the corner and I include the paving stones, which add a little bit of extra height, I get actually like very close to 147.46 meters. Now, how does that connect to the Indus Royal Pendulum Cubit? Is an Egyptian Royal Cubit plus 3 millimeters. If I multiply this by 440 is the base, but if you look at it three-dimensionally, what you get is 880. That's the maximum visible, is 880 Egyptian Royal Cubits. If I include the sockets, multiply the Indus Royal Pendulum Cubit by 880, what I do is I get the base of the pyramid, including the sockets. If I multiply this cubit by 280, again, there's a little bit of, basically what I get is the height of the pyramid, including the paving stones. So if you include the paving stones, divide it by this, you get the height of the pyramid including the paving stones. Okay, if I multiply this, the Indus Royal Pendulum Cubit, by 880, which is the maximum visible base, I get the pyramid including the sockets, which brings us back to 86,400 seconds per day, which is the whole point of all these pendulums. We have the maximum visible base of 880 Indus Royal Pendulum Cubits and 280 height of Indus Royal Pendulum Cubits. I multiply this by 86,400 and I get above 99.9% the polar diameter of the Earth. If you use the 43,200 method, you get only the radius, so you get a half measure of the Earth size, yet you get the whole circumference. But if you use 86,400, a three-dimensional, just one, you don't have to look from the top and then from the side and then do this stuff. All you got to do is look from the corner, you take the maximum visible measurements, okay, and the height times 86,400, you get the polar diameter of the Earth, again above 99.9%, probably, until very recent technology, you would have been pretty much spot on. Now we put the maximum visible base. Before we move away from that, well, what's the rotation speed of the Earth per second? Well, pretty much spot on to that number. So that's 1 second, back to the second. Rotation of speed of the Earth per second is the maximum visible base of the pyramid, including the sockets, which is 880 times this number. Second, okay, so therefore by definition, times that by 86,400, we get the equatorial circumference of the Earth. Now just remember the Indus and the Egyptians, as well as the Sumer, this is all connected, call it coincidence if you want, but these are all nicely joined together. And so the size of the Earth in relation to the pyramid, you need the sockets and the paving stones, and that just happens to be exactly the same number of Egyptian Royal Cubits to get the pyramid. Use the Indus Royal Pendulum Cubit and you get the pyramid, including the sockets and the paving stones, which sets it at the size of the Earth at the number of seconds per day. 30 degrees, well, Giza Plateau is 30 degrees north. That might be a pure coincidence, but there's a bit of yellow. Well, seconds, speed of the Earth per second, second metre, cubit, these different measures all coming together, including the square root of 2, pi, phi, e. Now we also have these, so not only is the Earth rotating, it's also going around the Sun, and at the top speed it's going around the Sun at 30 kilometres a second, or 1800 kilometres a minute, or 108,000 kilometres an hour. 1 metre, 1 second on a 30-degree pendulum. 30 degrees, 30 kilometres a second. 30 degrees breaks down into, you break a degree down into 60 minutes and then into 60 seconds. So 1800, 30 degrees is 1800 minutes on the compass. The Earth is travelling around the Sun at 1800 kilometres a minute. 108,000 seconds makes up 30 degrees. The Earth is travelling around the Sun at 108,000 kilometres an hour at its fastest point. So we have all this foot, metre, cubit. The difference between the foot and the Egyptian Royal Cubit 4/7 is the definition of a second. 1 metre minus 1 foot minus 4/7 of the Egyptian Royal Cubit gives us 1 second pendulum of 99.43 metres. 1 metre defined by the speed of light gives you the Egyptian Royal Cubit, which is E minus 1 feet, which Egyptian Royal Cubit is pi over 6 metres. Pi over 2 Indus feet, which you get by definition by this pendulum, which is 1.0584 metres, gives you the Indus Royal Pendulum Cubit, which scales the pyramid to the size of the Earth at 86,400 seconds per day, and it also works out to be 1 canonical cubit, 1.728 feet, which is 6/5 cubed. Egyptian Royal Cubit plus a metre is 5 foot. Foot plus a metre plus the cubit plus a metre is 6 foot. 6/5. While you're at the pyramids, where else is 6/5? Well, it's so many places, but for instance, staying at the Great Pyramid, okay, you have your internal chambers and stuff, but then you have the subterranean chamber, so it's 280 Egyptian Royal Cubits high and it's 440 Egyptian Royal Cubits wide, but because you have this subterranean portion, that makes it another 56 Egyptian Royal Cubits, so that's 336. That's at a 5:6 ratio. 336 over 280 equals 6/5. So the height, maximum visible height of a pyramid, the maximum invisible height of a pyramid, including the subterranean, is 6 to 5. 6 to 5. 6/5 cubed is 1728, which gives us this unit. Now, of course, you have the square root of 2 here as well, and the margin of error between 4/7 of a foot of a cubit and a foot gives us what we need exactly to find the 1 second pendulum. If you're defining it by there, but then the metre currently defined by the speed of light gives us the Egyptian Royal Cubit, which is pi over 6 metres again. This one gives us the size of the Earth at 86,400. This one gives us the pyramid. The pyramid proportions and ratios are all phi, pi, all these other numbers, and if you use metres to this metre to measure it, what you get is not only a ratio of phi and pi and e, you also get the measurements in metres turns out to be those particular numbers. What's in ratio is repeated in measurement, and it all comes back to these ancient units of measure, including the Canonical Cubit. Now, there's also the Doric, Ionic and Corinthian. If you apply those to these things, there's a crap storm more of information to be emerged from this. Now, all these units are meant to be either pseudo-scientific or unconnected, so Indus, foot, Egyptian Royal Cubit, metre, these are accepted. Cremona's basically disappeared. You have to go back to books 200 years old to really find any mention of it. Canonical Cubit said to be, it's got a bad name because it's from John Michel, amongst others, but E, pi, phi, Euler's, second, cubits, metres, these ratios, speed of the Earth around the Sun, speed of rotation of the Earth itself, the size of the Earth, because it's a bit flattened at the poles. So the equatorial circumference is a little bit more than the polar circumference, but we have the polar diameter, which explains this flattening. 30 degrees where the Giza Plateau is 30 degrees, which goes back to the speed and size, and it just goes on and on and on. And this is measure of Caduceus, of Hermes. Hermes was a god of weights and measures. That's why it's Hermeticism. That's why all these people, Riccioli, Roma, Mersan, Jefferson, Washington, these guys were all embedded in the geometry. Yeah, that's what they're all. That's what this all comes down to: geometry and measurement, and these ancient stuff. And so Hermeticism is not this fluffy stuff. This Caduceus is actually a wand, and the wand translates to a measuring rod in the original Greek. The Egyptian equivalent of Hermes, Hermeticism, was Thoth. He was also the god of weights, measures, knowledge, engineering, science, and etc. Hermes and Thoth were not, Here we have so much understanding, knowledge of our world and measurements of time, measurements of length. With this you can build a society, with this you can bring peace. The olive branch, it's a wand made out of an olive branch. To extend an olive branch is a sign of peace. If you have standardised weights and measures, you have, well, some of the best agents for a peaceful, prosperous society, because at least everyone agrees on what these things are. There's not much we can agree on, but if we can set up some standards, we're well on our way to having a peaceful, intellectual, reasonable, intelligent, and of course there are so many other aspects to go into this, but man is the measure of all things. So pretty much between 6 and 5 feet you have, the size of your arm, ideally speaking. So for instance, the Greeks were looking for the perfect proportions of a man to base their temples on. This is it's not just biology, it's also how to apply biology to architecture, to astronomy, to arithmetic, and also you can extend this further into the musical realm. And based on these E, square root of 2, pi, phi, just to begin with. So there you go.